Hi friends, today we are going to discuss about the methods of preparation of amines. And at the end of these methods of preparation, I will be discussing some of the mind maps which will be helpful for you to do some important conversions. So let's start with the methods of preparations. We know that amines are the organic compounds which containing a functional group like NH2. So RNH2 is the general formula of aliphatic amines. So now let's start with the preparation one by one. First preparation is from nitro compounds. So here you can see nitrobenzene by using hydrogenation or reduction in presence of palladium and ethanol, or by using tin in HCl, or by using iron in HCl, we can convert this NO2 to NH2. So you just study like this RNO2. Wherever NO2 is coming, it can be attached with the aliphatic group or an alkyl aromatic group. This NO2 can be changed to NH2. NO2, nitro to NH2, amino. By using any of these reagents, it can be number one is reduction by using palladium and ethanol. Number two is reduction using tin in HCl. Number three is iron in HCl. Any of these reducing agent can be used to convert NO2 to NH2. So you just study the general formula. That is number one. Second one is ammonolysis of alkyl halide. Alkyl halide is RX. RX. This is alkyl halide. You have to add ammonia to alkyl halide. So you will get a substituted ammonium salt, and that substituted ammonium salt is on reaction with NaOH. You are getting primary amine. So instead of studying these two-step reaction, you can study like this. RX on ammonolysis, add ammonia over the arrow mark NaOH. So this is how we can combine these two reactions. We get RNH2. So here the reaction is X. Halogen is replaced by NH2. Halogen is replaced by NH2, conversion of an alkyl halide to alkyl amine. But the drawback of the method is when you do the reaction, you will get a mixture of primary, secondary, tertiary, and quaternary. Why? Because Rx is excess. Instead of taking Rx excess, because of taking Rx excess, you are getting after primary that will be changing into R2NH and then R3N and then R4N plus X minus, which is quaternary ammonium salt. But to avoid this mixture preparation, to prepare only primary amine, instead of taking Rx excess, you have to take ammonia in excess. So the reaction will stop here. No further reaction will be taking place. So that is how you can stop the preparation of the mixtures of amines. And always the alkyl halide the reaction order, as we know that it should be Ri, Rbr, RCl. This is the order. Why? Because iodine is bigger in size, it acts as a better leaving group, so the bond can be broken easily. That's the reason. So the second conversion is halogen is replaced by NH2 by adding ammonia in presence of NaOH. Next is nitrile. Nitriles are cyanides. RCN, RC triple bond N. Reduction. H2 adding in presence of nickel, sodium amalgam and ethanol. In presence of these all reagents, when you do reduction, the bond breaks out of C triple bond N. Two pi bonds are breaking and hydrogen H2 is added on either side of the triple bond. So it becomes RCH2 and H2. So that is reduction. RCN changes to CN changes to CH2 and H2. Now reduction of amides. Amides are the organic compounds with the functional group CONH2. So RCONH2 is a general formula of an alkyl amine. On reduction, again by using a reducing agent like lithium aluminum hydride, that CONH2 part changes to CH2NH2. So mainly the CO part is changing into CH2 reduction. But the same amide, by doing another reaction which is called the Hofmann-bromamide degradation by using bromine and alkali. Instead of bromine plus NaOH, we can write NaOBr as well. So in this reaction, this CO part will be deleting and writing RNH2 as a product, RNH2. So in this reaction, one carbon is less than that of the reactant. The product is RNH2 but the reactant is RCONH2. So So the product with one carbon less than that of the reactant, so that it is called a degradation reaction or step down reaction. One carbon decrease reaction, step down reaction. So in these two reactions like reaction 4 and 5, in both the case amide we are converting into amine. But if we follow lithium aluminum hydride like RCONH2, if you do lithium aluminum hydride reduction, we get RCH2NH2. But if you add NaOBr to this, you will get RNH2. So this is the reaction. For example, if you are taking CH3CONH2, like ethanamide, CH3CONH2 having 2 carbon ethanamide, you will be getting CH3CH2NH2, which is ethanamine, if the reduction is carried out by using lithium aluminum hydride. But you will get CH3NH2, which is methanamine, if you follow Hofmann bromamide degradation. So two different products but the same reactant because the path of reaction is different. Okay, so now the last preparation is Gabriel thialamide synthesis. In this, we take thialamide. Thialamide is the one with the benzene ring, C double bond O, which is connected through NH bond. And by adding KOH, we need to add KOH in this. The bond between N and H breaks, so that this hydrogen will go with this OH as water went, so K will be coming here, so it gives NK, which is potassium salt of thialamide. Now we have to treat it with the RX. So again NK bond breaks, RX bond breaks. This K will go with this X as KX, minus KX is eliminating. So this R will be coming in place of K. We get NR, which is alkyl salt of thialamide. After that you take alkyl salt of thialamide and do reaction with the NaOH. You need to take 2 molecules of NaOH. So to show the reaction I am writing NaOH 2 times, and in this Rn will go with this 2 hydrogen atoms of NaOH. We get RNH2. RNH2. That is RNH2, that is primary amine. And the remaining or the byproduct is this ONA will be attacking with this carbonyl group, and the next ONA will be attacking with this carbonyl group. So this is how the byproducts are formed. So these are the important preparations of amines. So I'll just conclude all the preparations. We studied like this. If you have RNO2, you take tin in HCl. Reduction by using tin in HCl, we get RNH2. Or if you have RX, alkyl halide, you add ammonia followed by NaOH, you will get RNH2. Similarly, RCONH2, amide if you have, do the reduction in presence of NaOBr, which is Hofmann bromamide degradation. Also you get RNH2 by deleting RCONH2, RCO, carbonyl group, and again the same reactant only, RCONH2, but this time when you add lithium aluminum hydride, the reducing agent lithium aluminum hydride, you get RCH2NH2, preserving the same number of carbon atoms. And then you studied this also, RCN, nitrile. By using reduction in presence of nickel, you are getting RCH2NH2. So this is how you have studied just now. Other than this, you studied Gabriel thialamide synthesis also. So using this, I'm going to give you an important mind map which will be helpful to do the conversion which are coming under this particular topic. So in that, I'm going to start with ROH, which is alcohol. Alcohol, we can change it into alkyl halide. This reaction you have studied in haloalkanes and haloarenes. There are different methods. One among that is SOCl2, adding thionyl chloride. Other than that, we can use PCl3, PCl5. All those reagents can be used. So anyway, this OH can be changed to X by adding this reagent. And now to this, when you add KCN, you get RCN, alkyl cyanide. To this alkyl cyanide, when you add reduction, when you do reduction in presence of nickel, we get RCH2NH2. So this is just now we studied RCH2NH2. And now that RCH2NH2, when you do the reaction with the HNO2, this we will study in the coming topics, which is the distinction test for amines. HNO2, nitrous acid or diazotization, it changed to alcohol, RCH2OH, means NH2 changed to alcohol. And now we take again this from this RCN. I'm going to start with RCN. By doing acid hydrolysis, we get RCOOH, acid, carboxylic acid. This reaction is coming in aldehydes, ketones, and carboxylic acid lesson. And this carboxylic acid can be changed to RCONH2, amide, by adding ammonia followed by strong heating. This reaction is also coming in that same lesson only, means acid to amide. And now this amide, we can change it into RNH2 by decreasing one carbon by using Hofmann-bromamide degradation. Or to this, if you add lithium aluminum hydride, a reduction by using lithium aluminum hydride, we get RCH2NH2. Okay. So now from this RCH2NH2, you change to RCH2OH, alcohol. That alcohol you can convert it into acid by using alkaline KMnO for oxidation in presence of strong oxidizing agent like alkaline KMnO4. Okay. Now from this alkyl halide, when you take alkyl halide and do the reaction with the AgNO2, this reaction is coming in haloalkanes and haloarenes. You get RNO2, and in this lesson you studied how to convert RNO2 to RNH2 by using lithium tinning HCl. Okay, and again from the starting of this I have written alcohol. That alcohol from amine RNH2 we can prepare by adding HNO2. So these are the important conversions, mind map. You see, from this beginning, yeah, from this beginning, we have amine. We can prepare alcohol from amine by adding nitrous acid. That alcohol group changed to halogen by adding SOCl2. Halogen is replaced by cyanide by adding KCN, and this to this means RX to KCN is called a step-up reaction. Why? Because one carbon is increased. So wherever you are getting a question to increase one carbon, the best method to introduce CN group by adding KCN. But remember that KCN can be added if it is RX. If it is not RX, you convert the particular compound into RX. And then that CN changed to CH2NH2 by using reduction in presence of nickel, and that amine changed to alcohol again. That alcohol can be converted to acid. This acid you can prepare directly from CN by doing acid hydrolysis. Amide to this acid to amide RCONH2, amide to amine with one carbon less and having same number of carbon atom. Two important preparation just now we have studied. And from this alkyl halide to nitro compound and nitro to amino compound. So these are the important conversions. So suppose if you are getting a question like I will show you where to use like step up and step down reaction. If you have ethanamine, you need to convert it into methanamine. Methanamine. So when you check the root word, you can understand eth to met, one carbon less. So we need to think which method or which route we need to follow. Ethanamine. Ethanamine, first you write CH3, the formula like CH3, CH2 and H2. Okay. And methanamine we know it is CH3 and H2. First always you write the formula of the reactant and product. Now you have to think about the path. Path is like we can convert. See, this path you can follow. This RCH2NH2 to RCH2OH and then to acid and then to amide and then to RNH2 by using Hofmann-Bromamide degradation. So you take the amine and do the reaction with the HNO2. So you will get CH3, CH2, OH, alcohol. That alcohol you take and do alkaline KMnO4 add that is oxidation in presence of alkaline KMnO4. We get CH3, COOH, acid. Acid to amide we prepared by adding ammonia followed by strong heating. We get CH3, CONH2. Now amide to amine by Hofmann-Bromamide degradation. This is how we can decrease the carbon, which is step down reaction. Now just opposite. How do we prepare methanamine to ethanamine? How can we increase the carbon atom? Again we write the formula. CH3 NH2 is methanamine and finally we need CH3 CH2 NH2. So we need to think about in which way we can increase the carbon. So increasing the carbon or step up reaction is this only. If we have R and H2, first we convert it into ROH and then we can convert it into RX and then we can convert it into RCN and then we can convert it into RCH2 and H2. So you take methanamine and change it into alcohol first. For that we need to add HNO2, nitrous acid, and then you can add SOCl2. We get alkyl halide, corresponding alkyl halide, and then CH3CN. Cyanide you prepare by adding KCN, and then from CN we change it into RCH2NH2, that by reduction in presence of nickel. Okay, so these are some of the important type of conversions can be asked in this lesson. So learn this mind map thoroughly from this method of preparation, because this lesson is connected with even the other lessons like haloalkenes and haloarenes and also aldehydes, ketones and carboxylic acid. Let's do 2-3 questions more. Write the chemical reactions of the following. See, C2H5Cl is treated with the ethanolic ammonia, which is ammonolysis. So you take C2H5Cl and add ammonia. When you add ammonia, the Cl is replaced by amine, C2H5NH2. So this is another type of question which are coming under this topic. Ammonolysis of benzyl chloride. Benzyl chloride is C6H5CH2Cl. This is benzyl chloride. Do ammonolysis. Add ammonia. First you will get C6H5. CH2, Cl is replaced by NH2 group. And they are telling the products of formed is treated with the 2 moles of CH3Cl. So to this you add 2 molecules of CH3Cl. That time the 2 hydrogen atom of this amine is replaced by 2 alkyl group. This 2 CH3 group will be coming in place of hydrogen. We get C6H5 CH2N CH3 twice. It is like this is primary amine and this is tertiary amine. So primary to tertiary. But if you add 1 molecule of CH3Cl, you will get C6H5CH2 NHCH3. It is a secondary amine. Similarly, propanamide to propanamine. Propanamide is CH6 CH3 CH2 CONH2 is propanamide. Propanamine is CH3 CH2 CH2 and H2. So you see the number of carbon atom. Same number of carbon atom. If it is same number of carbon atom, you add lithium aluminum hydride. Reduction by using lithium aluminum hydride. But the second question is propanamide to ethanamine. Ethanamine is CH3 CH2 and H2. So for that we need to add NaOBr. Hofmann-Bromamide degradation. Got it. Now Hofmann-Bromamide degradation of butanamide. Butanamide is changing into not butanamine, it will be changing into propanamine. One carbon should be less than that of the reactant. Got it? Now you see the conversion. CH3CH2Cl, we need to convert it into CH3CH2CH2 and H2, one carbon extra. So for that you start with the CH3, CH2, Cl is replaced by Cn by adding KCl. And to this you add or do reduction in presence of nickel, you will get this. Cn changes to CH2NH2. Got it? Now amide. The amide which gives propanamine. We get propanamine by using Hofmann bromamide degradation. Which amide? Which amide we have to select to get this product? Since it is propanamine, the amide should be butanamide, one carbon extra. Because during Hofmann bromamide degradation, one carbon will be less. Now, the amine produced during benzamide of Hofmann bromamide degradation. Benzamide is C6H5C CONH2. This is benzamide. When you do Hofmann bromamide degradation, one carbon will be deleting, especially the CO will be deleting. You get C6H5NH2, which is aniline. So the answer is aniline. Got it? So these are the important type of questions and important type of conversions comes under this topic. So basically you study this mind map which will be helpful for you to do any of the conversions comes under this topic. So I hope you understand. Thank you.